In this video, we're going to look at a concept that's related to precision and accuracy, and that is the tolerance in a given measurement. Specifically, we're going to calculate maximum and minimum values using a given degree of tolerance. The outcomes we're going to cover include calculating maximum and minimum values using a given degree of tolerance in context, and solving a problem that involves accuracy, precision, or tolerance. So to start, we have here a definition. Tolerance is the total amount that a measurement is allowed to vary. In other words, if we're given a certain measurement, it tells us what is the maximum and minimum acceptable limits on what we can include for that measurement. Here's an example. So if you've ever seen a survey provided in the news, whether on TV or in the paper, you'll often hear statements such as this, 36% plus or minus 3%, and that's given as accurate 19 times out of 20. What we're going to concentrate on for this is the 36 plus or minus 3%. The tolerance in this measurement would be 3%. What that tells me is that I can have 36% plus 3%, which is 39%. So I can have a maximum measurement of 39%. Or I can go as low as 36% minus 3%, which is 33%. Okay, so I have a tolerance in this measurement of 3%. So I can have acceptable ranges as low as 33% and as high as 36%, sorry, that should be 39%. So 39% in a measurement. So I have something given to me as 36%, and it has a tolerance of plus or minus 3%, which means I have an acceptable range of values as low as 33% and 39%. So 19 times out of 20, if I do this survey, I'm going to get answers between 33% and 39%. So we're going to use this concept now in a problem. A clothing manufacturer allows for a certain tolerance when making their products. Men's pants are sold in whole inch sizes by their waist measurement, and often by their inseam measurement as well. The company allows for a tolerance of plus or minus 1/4 inches when labeling their products. So the first question is, what is the tolerance for the measurement of a pair of pants? The tolerance in this case would be 1/4 inches. They allow values that vary within 1/4 inch of the actual waist size. Second question, what are the maximum and minimum allowable waist measurements that can be labeled as 32-inch waist pants? So 32-inch waist pants can have a variation of 32 plus or minus 1/4 inches. So that gives us a maximum value of 32 plus 1/4 inches, or in other words, 32 1/4 inches, and it gives us a minimum value of 32 minus 1/4 inches, which works out to 31 3/4 inches. So we have a maximum value of 32 1/4 inches. We have a minimum value allowed of 31 3/4 inches. Third question here is, what is the largest difference possible between two pairs of pants? In order to determine the maximum difference allowed between two pairs of pants, what we have to do is take the maximum value and subtract from it the minimum value. Get the difference between the maximum and the minimum values. So the maximum value allowed in this example was 32 1/4 inches. The minimum value allowed was 31 3/4 inches. The largest difference possible between these two pairs of pants, or the range between these two pairs of pants, would be 1/2 inch. So I can have two pairs of pins that varies by as much as 1/2 an inch and still call them both 32-inch pairs of pins. Okay, to summarize, tolerance indicates the greatest and least allowable values for a measurement. What is the largest acceptable value and the smallest acceptable value that we can take for a certain measurement.